Yeah, thank you for the nice introduction. I'm happy to be here today and to tell you a little bit about selection of the right pelletizing system. And this is the agenda for today. So I will briefly introduce Mark to you, what happened since the last 2 years, as I've been here also on the last ICMBA and gave you some announcements on that. Then we talk about criteria for selection of the pelletizing systems, then which systems are available for compounds and master batch. And then we go in comparison first on Strand and then Strand compared to underwater pelletizing. Then I give you some examples and close with a summary. When I've been there 2 years ago, I announced the merger between Mark, Gala, Automatic and Shear. And I want to just jump on a small video which I have brought with me, where you can see what happened in the past. So we did some work. We made some work to bring the two companies together. And so out of Mark, we made Mark pump and filtration systems. We joined then Shear and Automatic together on the Strand Pelletising Systems, so to form Automatic Shear Strand Pelletizers. We joined Gala and also Automatic together to make Gala Automatic underwater pelletizers. And at the end, there was, from reduction engineering in the United States, we got pulverizers in our product portfolio, and this is now reduction pulverizing systems. So by doing this, of course, we wanted to be close to our customers. You can see this is our landscape around the world with the headquarters in Europe, a lot of manufacturing sites in the United States, and also a service center which we opened roughly a year ago in Vadodara here in India. So also here to get closer to you. And we had, I think some of you joined our nice opening ceremony. Could see the facility. We have there a grinding center for cutting rotors. We can do bed knife grinding. We can do grinding for underwater pelletizers, the die plates. We have field service. We have some spare parts supply and improved also the number of people so that we serve you much better. This is generally the product range. So I don't want to touch this in detail. You can see this in your here on the slide. And I just want to start to talk about what are selection criteria for pelletizing systems. Generally, of course, there are a lot of criteria which we have to consider, or let's say which you also have to consider. This is, of course, the material you want to produce. These are production costs. But these are also other things like what is your recipe? Is it very expensive or is it a normal product? Do you have a frequent product change when you change colors, when you change the polymer itself? And this all has an influence on the system which you want to select. Then, of course, there are requirements from your side. So what do you already have in your portfolio? Which machines do you use already? What is the technology you use? What is the space which you have, capacity, and what is your process you want to use? Then, secondly, there are, of course, technical requirements, which are mostly product related. So this means your product is abrasive or moisture sensitive, can be shear sensitive as well. Then what do you want to do? What do you want to have a dedicated line to one product family, or do you want to have a high flexibility? What are the skills of your operator in your plant? So these are all things which need to be considered and are decisive for your selection. Of course, we don't, or we need to consider, of course, also the commercial requirements. So anytime you can select whether you take a Primo Strand Pelletizer, for example, or a Primo Plus, which is the upgraded one, or even go to an underwater pelletizer. So this all comes then in production costs and, of course, shows your investment. And then another factor, of course, is what pellet size or pellet shape do you want to get? Do you want to have the typical cylindrical pellets or more round or spherical pellets? And if you look at this, you can see it here. I brought two examples with me. That's the upper one is a polyester, one made on an underwater strand pelletizer, so you get nice cylinders. The other one on an underwater pelletizer, where you get some kind of round or egg-shaped pellets. The other one is a compound PLA with bamboo, also one made on a strand pelletizer and the right one made on the underwater pelletizer. So you see the difference. But what is actually the big difference? I mean, if you choose cylinders or choose some round pellets, and one of the factors is the bulk density. So anyway, when you have pellets which are round, you can see it here on this slide or this figure, more pellets fit in one bag. So if you fill the big bag, you can get more pellets in the same bag at least. If we look at other criteria, so we already talked about the bulk density. We're looking at fines or dust. Underwater pelletizing normally has less dust, less sticking points, so they don't stick together. The pellet size distribution on strand pelletizers is normally better, so it's plus minus 5%, so you have a more narrow distribution. And what is also important on the selection of the machines itself is the pressure drop you are going to generate. I come to that later, so you will see the difference why the pressure drop is on a strand pelletizer always less compared to an underwater pelletizer. Now, what is available? What do we have? The upper one, I think this is what everybody probably knows. Typical one, strand pelletizer with a water bath. Then the second one here is a fully automated system for compounds. And the third one is a semi-automatic belt system where a belt brings the strand into the cutter. The upper one is the most flexible one, has the less costs, can run, in this case with smaller machines, up to 70 strands, but generally is available also with up to, I think, 150 strands, but which are a little bit difficult to handle. The so-called jet stream system, so this automated system can go up to 120 strands, fully automized, and the largest system we could supply so far to a customer was for glass fiber reinforced nylon, 9 tons per hour, continuously running. And the last here, as I mentioned, the so-called EBG system, semi-automatic belt, where the strands go here straight into the cutter, can be handled 50 strands, around 2 tons per hour, and is for highly filled or also for moisture-sensitive products. Now, another system for strand pelletizing is the underwater strand pelletizer. So we have underwater pelletizer where we make the spherical pellets, but on the other side we also have underwater strand pelletizers. And I will show you also there a small animation. I hope you can see that. Yep. This shows how the system works. And it is a self-threading system, so you don't need to take care of pulling the strands through a water bath. So your strands come out of the die over here. So now the strands are coming, you purge your extruder, and then the strands are cut by such a knife and fall on the sluice here. So there's some water guiding the strands down, and there's some additional water coming from the top to cool the strands and to create more turbulences on that water bath. So this is done fully automatically, and if a strand breaks, it is fed automatically again into the system. And then the two feed rollers here take the strand, feed them to the cutter, and the cutter cuts continuously the pellets. Now the pellets are in the water, so the water and pellets slurry goes in a cooling pipe. Cooling pipe length also depends of the polymer, and then they are directed to the dryer. Here we still have a small agglomerate catcher. So you imagine if you have a strand break, and then a bigger lump is coming at that time, and this lump is catched here at that position. And then, of course, the pellets need to be separated from the water again, so we have a centrifugal dryer where the pellets move up and are dried, and then we have a counterflow of air which takes the moisture out of the dryer. This is generally how such a system works. Of course, what is needed also here, you can see it, is the water preparation. So you need some filtration, a tank, a water pump, and a heat exchanger. So it's a closed system to get the water in a circle, in a loop. Now, if we compare this now to underwater pelletizing, this is a little different. So there we don't produce any strands, but we cut immediately on the die. And I want to show you here how it works on the example of a Perlo Flex. So this shows also a complete system mounted on one frame. And here it's a little different. When you purge, you need to put this device into the die. Then your melt is coming, and you purge the die plates, the die holes, until you see that all holes are free and free flowing, so there's polymer on each hole. And then you clean it, you go in waste position, and next step is you remove this device here again. Then you close the system, and then you're more or less ready to start the operation. So this means, of course, now, first of all, the rotor starts to turn. Then we need water, of course, and more or less at the same time when the water is coming, we also, of course, need the polymer. Otherwise, the holes would freeze in. So this is a timing which must be very exact. If this doesn't work exactly, then you create just a lot of trouble because of freezing holes, because there's always, of course, water around the die holes. So now our pellets are cut. As soon as they look out of the hole, they are cut, and immediately they get out of the water box and go to the dryer. So this is again a kind of centrifugal dryer, which is here located directly on the water tank. So that's a very compact system here. And the water can flow immediately downwards in the dryer here on this device, and is then dust is removed and the water goes back into the system. So this is generally, let's say, what is nowadays available on the market to produce compounds and master batches. Now, I mentioned big differences in the strand pelletizers. If we just look there, which one do you want to use, or what is the best for your application? Of course, this machine, a single machine with a water bath, is the most flexible one. So very flexible for product changes, very flexible in variation of fillers. You just take the strands earlier out of your water bath and you are done. You can adapt your capacity with a number of strands, of course, and also the output you can adapt also on the variation of the strand speed. Even if you need to clean, for cleaning, okay, you have to clean this, all these components which you see here, but generally this works quite quickly. And if we now go on, let's say we have a very high sophisticated polymer which is very expensive, or really you tend to go on a high capacity. Normally these automated systems, they start at 2-3 tons because they have everything inside. Yeah? So they have a water sluice. I can show you the video, by the way. It starts similar like the USG. So you cut the strands also. You move this plate forward, then the strands fall on this water conveying, and then they go on a belt. And during the time here, we take away the water, and there are some suction devices here in this area on the belt or underneath the belt, and there we eliminate the rest of the water. So at the end, what we do here with such a system, we also cut in a dry condition. So there's no more water around when we cut. So there's also no post-drying required. Of course, we play with the heat of the pellets. So we want to get hot pellets so that we have no more moisture around. And as you could see this also in the video, this system works fully automatically. But there's of course also a small disadvantage. There is only a medium flexibility if you want to change polymers. So if you have this is more or less dedicated to one product family. Let's say you produce nylon from 10% glass to 50% glass, it works perfect. But if you want to say, okay, tomorrow I want to change to polypropylene, this does not work because this distances, this lengths here of the sluice and the length of the belt, they are fixed, they cannot be changed. Yeah, these are some other details. We have a quick exchange, of course, of the cutter for really a minimum downtime. And those systems, they produce a quite low moisture content. Now I come to the so-called EBG system, belt system. As I mentioned, this is a system which goes straight. So you can see this here on this picture again. The strands go really straight. There's no bending of the strands and therefore also no breaking of the strands. So if you have strands which are high filled, more than 60% or very heavy strands, they can go straight into the cutter. Another interesting application of this is a very, let's say, when you have to produce very slowly, for example, these are sometimes we had it for PEEK here. Another application is for polymers which do not allow any content of the water. So if you say, no, water is not allowed because it's too sensitive or it will soluble be in the water, this can be cooled by air only or maybe by some spray of the water, but generally more or less without water around. I mentioned the USG, so that's my last strand application. You can see it here, the USG is more or less used underwater strand pelletizer for most of the virgin polymers and also for polymers which are filled with additives or with colors, like we have a lot of application with white master batches, with black master batches as well, and also with other additive master batches. And as I mentioned, advantages of course here are it's automated process, strand breaks go in again automatically, So you don't need a lot of labor around, so this, once started up, it works. There's a long lifetime of the cutting tools, only a little dust generated and can be used for long campaigns. It's not good if you change today from white to yellow and back to yellow again. This makes no sense because then you have too much cleaning. So this is what I mentioned. The cleaning is one of the disadvantages if you change the product too often, and it's dedicated to a certain product as well, because you have this strand guide section, which is responsible for the cooling, is also fixed. Yeah, so this is, if you have a 3 or 4 meter strand guide section, it is dedicated then maybe to nylon, to polyester, or something like that. Okay, now I come to my last comparison between strand and underwater. You see, the pelletizing itself is a huge field of machinery, and now we go really into different processes. This means I already told you, we have differences, of course, in some mechanical features like the bulk density. You can see here also a lot of strand pelletizing is in the market, around 80%. The noise level of strand is a little bit higher because you always have an inlet and an outlet, which you cannot cover so properly. But if you look at maintenance, for example, is much better on a strand pelletizer because you can run this longer. Cleaning time is shorter. And if you look at investment, the strand pelletizer is cheaper than the underwater pelletizer, but on the operating cost, it's just the other way around. And at the beginning, I said the pressure buildup in the extruder is also different. It is, on the strand pelletizing, can be up to 3 times less, and the reason is really because on a strand, you have let's say a 4 millimeter die, and out of that you stretch the pellets or the strands to a 3 millimeter pellet. If you want to achieve a 3 millimeter pellet on an underwater pelletizer, it's just the other way around. You need a relatively small hole, like here 2.4 millimeter, and out of this you get a bubble which comes out, and this has to be cut, and then you achieve a roughly 3 millimeter pellet. So you can see a big difference between 2.4 millimeter and 4 millimeter hole, of course, and then this also is the difference which creates a much higher back pressure for underwater pelletizers. So then, of course, this comes with a shear effect. This means on the strand pelletizer you have less shear on your product. Also, the heating of the die head on strand is not so critical because you just have the die head and then you have air around. On underwater pelletizing, you have the die head, but you have constantly water coming to the front, which of course is much more critical. If you look at strand breakages, of course, if you have underwater pelletizer, you have no strand breaks, so this is an advantage. Startup and stops and restarts. I think strand pelletizing is not so complicated because underwater pelletizing, you have to see whether it works well, whether the die head is not frozen, no holes are frozen in, and so on. Cutting tools. On underwater pelletizing, your cutting tools, let's say the knives itself, is a throwaway article. So when you use the 10 millimeter length of your knife, it's gone. It's somewhere in the water circles or somewhere else. So you cannot resharpen it. You have no choice of that. The only thing you can resharpen is time by time the die plate. So of course then the costs for cutting rotor are a little bit higher. So then I switch to the examples. I put some typical examples together. Like we heard from Steer, they made tests with 86% calcium carbonate. This, of course, we would also recommend an underwater pelletizer. Even the filler grade is high, but this is nearly let's say, very hard to cut on a strand pelletizer because you will get strand breaks all the time. Nylon 6 with glass fiber normally runs well on strand pelletizing. Sensitive, as I mentioned, or biopolymers, for example, would also go on a air cooling belt. Even shear sensitive melt, if you have something like this, would go on a strand. And then we come to the master batch where we have to really find out what do we have? Do we have a color master batch with 10, 15 times color change a day? Then the choice would be a cantilever designed strand pelletizer. Yeah, here again it continues. As I mentioned, for example, going on compounds with very high glass fibers, we would go on such a jet stream system, on a fully automated systems. When the glass fiber is lower, you can use both. Compounds with elastic components normally go also on an underwater pelletizer because sometimes it's difficult to have elastic, very elastic strands to feed them into a strand. What else do we have? Recycling, I did not touch. This can be done with both. Recycling can be done with underwater pelletizing, including online crystallization, for example, for polyester, but could also be done without online crystallization on underwater strand. And then it also depends a little bit if you have a lot size which is 5,000 kilo or higher, probably an automated system or underwater pelletizing system would be great. Smaller ones would go again on the strand. And capacity-wise, it is similar, small capacities, more in the range of strand pelletizers and largers on both systems. Now to sum up, if you would ask the question, what is better? It's difficult to say because there is no well or no good and worse, so both systems have their applications and we really have to decide case by case what we really want. And even if you look at the pellet shapes, they are both on the markets and they live side by side. Of course, sometimes people say in the future there will be no more strand because everything will switch to underwater pelletizing, but that's not what we see at the moment. So we think that also in the future both systems will live side by side. And yeah, we do this since a long time. I think we built the first pelletizers around 40 years ago. So there's a long time experience in virgin polymers and compounding. We are the experts with pumps, filtrations, so also screen changers. In the meantime, around 1,000 people around the globe and around 10,000 references in compounding and around 3,000 in virgin. So I think these numbers, they count on itself. And with this, I want to thank you for your attention. Don't be so shy. Now you have the possibility to ask me anything. But if you don't like, you can also come to our tabletop and talk to us directly. That's also the second choice.